go for the presentation again.
Thank you very much. So next, I will invite Dr. Adil Loya. His topic is implementation of flight controls on a flight dynamic model for an embedded controller. Please, Dr. Adil.
Hello.
Yes, please share your PowerPoint.
Yeah, I'm good. How are you?
Very good, thank you.
So shall I start with the slides? Shall I share the screen?
Share screen, please. Other
Okay, just give me a minute.
No problem.
Can you see the screen?
Yes, very good. Go ahead.
Okay. So the topic is the implementation of flight controls using the flight dynamic modeling. So what is it? It is just about, we have got flight controllers of different sorts, specifically designed by different companies, specifically Arduino, using Arduinos and the Pixogs, and as well as using the Raspberry Pis. So what our implementation is over here is that what we have done so far is that we tried to implement two things together, which was flight dynamic model in conjunction with the flight controller, which was not an easy task, because what we aimed was to have the most high amount of stability with our system. So for increasing the stability in the system, we needed to do this thing. And what we did was that, how we did it, so I will go with the flow, inshallah. So first thing is that an indigenous solution designed within Pakistan. This is the first beauty about our product. Second thing is that we can customize the GUI as per the user's requirement, whatever the user's requirement is there. And then flight dynamic model based flight controls will be, are applicable within this thing. And we have got the demonstrative prototype within our slides as well. So how does it works and how we got over here so far? So first thing is that we have got a direct RC command coming from the remote controller, which goes through the FDM, and with a UDP protocoling, it goes to the, a system where it is communicated. So it is communicated with a Qt based app, which is an executable control, and it is working on a Linux operating system. After communicating with that, what we do is that we communicate our telemetries and our communicative protocols within the system. And what it does is that it communicates with the flight dynamic model as well as the ground control station. So it is not, if we take an example, we can give you an example that there are two very well-known ground control stations at the moment, which are being run currently. One is the QGC, which is the Q ground control, and the other one is the other one is the wait a minute, it just went off my mind. One is the QGC and the other one is the mission planner. Yeah. So these are the two very well-known Q ground control. What our focus was that we didn't want to use their ground control stations. We wanted to make our own optimized version, by which we have got the fully control that we can optimize it as per our requirement and as per our users' requirement. So ultimately what happens is that the data is sent to the flight controller, and flight controller communicates with the hardware, and it runs the hardware on the onboard drone. And by this, what we do is that we control the total drone, and we can visualize it using an image generation tool as well, which is like a flight gear, or you can use the X-plane as well. So ultimately, our project, the novel aspect is that we are implementing the flight dynamic model with the controller. So people have done it, but most of the people, they have done it using the MATLAB. Okay, no one is doing it with respect to, or with the help of the C++ language. What we have done is that we have done it with the help of the C++ language. Now, in the next slide, I will show you our, what do we call it, the video, hopefully. So the fundamental aspect of designing the ground control station is to first establish an uninterrupted communication between the drone and the GCS. So we have successfully done this thing using the USB and the telemetry as well. But in future, we are planning to do use a GSM module as well, so increase the range as well. So now in the second phase, what we need to do is that we need to implement the flight dynamic model for this design. And the flight dynamic model for this design is, is the main heart of this total programming. Because in the flight dynamic model, what you do is that you describe the aerodynamic and the performance characteristics of our system. Now, this is the video, like what we have done so far, so you, to give you a good idea that how does it works. This is just the aerophysics is just the name of the drone we have plugged over there. So if you see this video, you will get a good idea what is happening over here. So currently we are trying to control this drone with the help of this GCS app. This is the app. We are trying to move the ailerons, and the ailerons, the control surfaces are moving on the, if you can see, on the wings. Then we are moving the elevators, which are on the horizontal stabilizers. So if you see, the elevators are moving over there as well. Our next phase is to go and fly this model. But for that, we are waiting for some of the sensors. So once we have got those sensors, then we will make it airborne as well. Then finally, we are able to move the rudder as well. All the control surfaces are inbound control from the GCS. And currently, this is being controlled directly through telemetry protocol. And now there is a throttle control over here as well. So if you see, I think you can hear the voice of the throttle control as well. So this throttle control, what does it does is that we are increasing the amount of the power, but since it's a throttle control port, we have removed the propeller from there, or else it will fly. So now this is done ultimately. So now in the next slide, this is a drone with a flight controller operated using a self-designed GCS. In the next slide, what you see is the laptop on the ground control. So this, what we use is that we just need to use a laptop for our application, and then we can directly inbound ourselves with the design software, and by which we can even entangle, and we have already entangled the autopilot modes as well for the lateral and the longitudinal modes. So we are using 5 PWMs for controlling our control surfaces and 1 BLDC for controlling the throttle control. So in the third phase was our basic autopilot design, in which we designed 2 autopilot systems at this moment, because they are the major autopilot for controlling any drone. One is the heading control, and the second one is the vertical speed. By vertical speed, we control the pitch, and by the heading, we control the lateral mode of the aircraft. Then these are the outputs of our design. One is in which we are showing you that how we are changing the heading and how stable it is when we give a heading of 300. What it does is that initially the heading was around 250, and after a couple of seconds, it went to 300 and it gets stabilized completely at that particular heading. And we are even working further on the design on the disturbances involved with the wind turbulence as well. So in the next slide, what you will see is the vertical speed. Okay, but the vertical speed, what we were doing is that since we were implementing a certain FDM of a certain commercial jet at this moment within this drone, because the thing was that we were interested to see that can we implement any kind of FDM within our particular design. So what you can see over is that initially the vertical speed is very stable, but as the height is increased,
Dr. Adil, you have 2 minutes more to conclude. Yeah,
it will be finished, hopefully. So once the vertical speed is increased from one point to another point, so what happens is that after a certain altitude, the vertical speed drops down due to the surface ceiling of the aircraft. So this is the autopilot input on elevator command. So ultimately, by utilizing our basic autopilot system, we can even design the GNC for this autopilot system, which is the guidance and navigation control module. Finally, we can cater any kind of user-based application with our prototype to accompany as per the requirements of our users. And thank you for our hopefully you have liked the idea of ours over here.